I was rather hoping that when I went down, I went along to the interview board and passed, and was taken on as an assistant experimental officer, not quite the lowest of the low, but the second lowest of the low, and then called in to see the astronomer role, hoping to go into astrophysics or one of the astronomical departments and solve all the problems of the universe. And he said, Malin, I've put you into the Mag and Met department. And again, not quite the lowest of the low. It could have been the Nautical Almanac office, but pretty boring. This was just doing the Earth's magnetism, producing charts, running magnetic observatories. Not the astronomy, which I'd hoped to do, but they had more telescopes than they had observers. So I got a lot of observing in. I was scheduled to observe several nights each week. And I was living in the castle, so at weekends I was the only one who was scheduled. The 36-inch, the App telescope, that's a big reflector there. I used that quite a lot. Didn't like it, it's a bit of a pig of a telescope, it's not easy to point and the sighting isn't brilliant. You're doing spectroscopy mostly. The other two I used were the 26-inch, the one with the rising floor. I think you call it the Thomson refractor. Mm-hmm. All very confusing because the Thomson refractor and the Thomson reflector, the only thing they got in common was that they used to be in the same dome at Greenwich, on the same mountain. So you could only use one at a time, which was very silly. Anyway, the 26-inch I worked on, doing parallax work, and the astrographic, the Carte du Ciel telescope in the little dome, the 13-inch. That was a lovely telescope. They both were. Both those two refracting telescopes were a delight. You could set they had wonderful setting circles. You could set the right ascension and declination and just go straight to the end, and there was the star in the middle. No stunting around, no messing about. Whereas with the 36-inch, you'd set it as well as you could, and then you'd spend another half hour trying to locate, to identify the star field and zero in on the star you wanted. I exaggerate, it didn't take that long, but it wasn't so good. I'll move to the next telescope now, which was the 26-inch, when I did most of my observing. And there, it was used for measuring the distances of stars, which you do by parallax. You take a photograph of a star tonight, say, you might sort of go out at midnight and see a nice star high up on the meridian and photograph it. And then you come back in 6 months' time and you photograph the same star, and it will have moved relative to the background stars because you're now on the opposite end of the Earth's orbit. The Earth has gone halfway around its orbit around the Sun. So you've got a nice long time base, and you measure the angle to the star by its movement against the background stars. The catch is that if I observe it at midnight tonight, in 6 months' time it's going to be up in the highest point at midday, which is useless. And the way around this was to observe intensively just after sunset for a couple of hours, and then you could sort of go to bed and it was somebody else's problem for the morning shift, and then again intensively just before dawn. So the first part of the job was to go along to the telescope half an hour before you started work and open up everything, all the doors and windows and the dome, and let the cold icy blast go through it. So by the time it got dark, it really was bitterly cold. So the Navy had these wonderful zoot suit things which you climbed into and you could zip them all up, and then they had like an electric blanket, they had wiring all around them. You plugged them in, not to the mains, you plugged them into a 12-volt transformer, and they would warm you up. So you could be warm, in theory, while the rest of the dome was freezing cold, literally freezing cold in the winter. They were lovely things. You couldn't move very far in them. A friend of mine used his an awful lot, and he did an awful lot of sitting down and standing up, and flexed the knees, and rubbed the wires raw, and it caught fire one night. Anyway, he managed to persuade the Admiralty to provide him with the cost of a new pair of trousers because they got singed as well underneath. Oh, and there were some gloves too, which did the same thing. You had these lovely silk gloves which were electrically heated, and clicked onto the contacts. And there's some thicker gloves outside, which was fine, except that you couldn't work the telescope with those. Try twiddling knobs delicately or guiding on a star. You just had to bite the bullet, take the gloves off and just get cold fingers. Because it was used intensively round about sunset and before sunrise, you didn't want to waste time getting from one star to another. Being a refracting telescope, it was pivoted in the middle, so when it was down near the horizon, one end was right up in the sky, and when it was in the zenith, it was down at ground level. So to speed things up, the whole of the floor can move up and down. This mechanism was made by the Wurlitzer company, and Wurlitzer organs are famous. They're the ones that rise through the floor, or used to, in cinemas. The main problem, as far as I was concerned, was that you were changing from one star to another. You would have to get the floor to a different level so it came up to within comfortable reach of the eyepiece, and also move the dome round so that the slit was facing towards the star you wanted. And if you did both of these things at once, looking up, see the dome rotating and you going up, it was the most nausea-inducing experience I can think of. When observing a star in the zenith, it's very uncomfortable to hold your head gazing straight upwards for up to an hour at a time. It wasn't usually that long, it's usually 10 minutes, quarter of an hour, but it could be quite a long time, and he got very uncomfortable. So, being a lazy devil, I solved this. I found a cushion, which I put on the floor underneath the eyepiece, and got the slow motion and just raised the floor. There's the eyepiece, I just brought the telescope up, just to there, perfect. And that was beautiful. The only hazard then was the danger of falling asleep, but I didn't do that. That was fine, and it worked a treat, and I thought I'd made a major contribution to telescope operation, until one day when I wasn't at the telescope, but they was having some maintenance done on it, and they were checking on the mechanism, and they raised the floor and pressed the up button and stopped pressing the up button, and the floor carried on going up and smashed into the bottom end of the telescope. I realised what might have happened if this had happened while I was sort of bringing it gently up with my cushion behind my head, but it didn't. But after that I just put up with a stiff neck. Meanwhile I was doing an awful lot of observing, not least because you've got 5 shillings a night if you're observing, whether you observed or not. Anyway, I would set the alarm for the morning shift, and the alarm would go off. First thing you do, you listen. Oh hell, I can't hear any rain. So, out of bed, over to the window, open the window, stick your head out, cross fingers, look up. Oh hell, stars, it's not cloudy. If it was raining or cloudy, fine. Back to bed, set the alarm for an hour later, and you're away. 5 shillings in your pocket, nothing done. But if it was, there's always the awful moment when you sort of look out and you see it's clear. Now, who else is going to know it's clear? Is there anybody else on duty? What happens if I say I didn't know? It's one of these things that goes through your mind just for a few seconds, and then you think, oh, hell, I've got to do it anyway. And once you got out of bed, you got dressed, and you got up to the telescope, great. Fairly great. It can get a bit tedious at 3 o'clock in the morning, but I didn't miss out on observing for that reason. And then after a night's observing, back to bed, and you were given the following morning off. Or if it'd been cloudy, you could have you had half a day off anyway, right. And 5 shillings, great. In the winter, it really was pretty miserable. I had an old Austin 7, which wasn't much good for the general roads, but we used it for getting around all of the, the sort of general purpose car. We used it for driving around the site. It was my car in theory, but anybody could use it. This car wasn't all that waterproof, so when it got hot, if you put antifreeze in it, it would just all run out.
Right.
So I didn't put any antifreeze in, and I would drive up to the equatorial group, and there's a car park at the back of it. And if I left the car there, it would be frozen solid by the morning, which I didn't want. So what I would do, between stars, I'd nip out the back, start the car, put it on full lock, and leave it in first gear just to go chugging round and round in circles. It was pretty accurate, it didn't deviate from that orbit much. And then I'd go back to the telescope, if it did, the curves to put it back on where it should be going. Go back to the telescope, take the next start, then nip out and switch it off for another hour. And this kept it warm enough not to freeze up. It gave the night watchman many a nasty turn when they saw this sort of driverless car going round and round in the car park. Not very fast. The equatorial group was carefully designed to be hazardous, particularly when it was, about the ha-ha. I never knew why it was called a ha-ha until I realised it was just sort of laughing at the astronomers who stepped over the edge. The main one was Philip Hill. Later on, he started as a vacation student, and later on he became the vice president of the Royal Astronomical Society, so quite a distinguished astronomical career. Anyway, he was a vacation student at Herstmonceux, and he came out of the astrographic telescope and went back to the main building and took the direct route, ending up in the lily pond. Who but a raving lunatic would put a lily pond in the middle of a place which is going to be used in total darkness? We had torches, but you tried not to use them much. You tried to keep your dark adaptation. And the whole place is designed to be a hazard. Let's go through some of the things. I've mentioned the ha-ha. You can just walk off the edge and drop into a 10-foot drop. And you're going around there in total darkness, remember. Also, the domes, he didn't like the look of the dome on the solar telescope because it had little prongs at the bottom which had a purpose. When you opened it, the dome, the shutter bit would slide out onto there. It was a little railway for it. And he thought, no, he wanted a perfectly smooth hemisphere. So that's what he designed. And then realised that not much use, you have to be able to open it. So he put in these shutters, and then they've got to run on something. So instead of just one obtrusive little line for them to run on down at the bottom of the hemisphere, he had 2 prongs sticking out, 2 up there and 2 down there. And they never worked. They were always jamming up. And it took hours and hours that somebody had to get up on a gantry and sort of crank it round by hand to shut it and to open it. And, anyway, that's one stupid thing. There are more subtle things. It looks a nice symmetrical pattern. You go in through the main door at the back and you come out and you see in front of you 3 domes. The 26-inch, what used to be the 28-inch, and the astrographic. And it's not symmetrical. If you go to the 26-inch, you go down there and turn right, and there's a step. And then you go along a little bit and go in. The other way, you go left, you go down there, turn left, go along a little way, and then down a step. Subtle, but just enough to be hazardous. Lily pond in the middle. Getting to the 26-inch, you had to walk over a bridge. There's the other entrance which comes in, and there's this bridge over the entrance made of York stone. Now, York stone is a very spongy sort of stone. It absorbs a lot of water, and when the temperature goes below freezing, it freezes and it becomes a sheet of ice. So you're going along perfectly happily, and suddenly you come to this bridge, and there were no railings there at the time. I think they put them there, but they weren't. There's a railing on the outside, but not on the inside. Again, just this 12-foot drop onto concrete, and suddenly your feet can go from under you. It's just sheet ice. Fiendishly clever man. I don't know what he got against astronomers. Final thing, the doors. If you look at the main office block, all the doors are all very elegant. Lots of verticals, and the general appearance is good by daytime. Remember, we were working at night. And the door handles, instead of being horizontal, normally you go to a door and go jonk, open it. Not there. The handles were put in so they were vertical, so they didn't spoil the line. And when you're half asleep at 3 o'clock in the morning and it's totally dark, you have to think like mad to remember you could go oonk instead of like that.